Quantitative literacy. This is the first video for the 12.4 and 12.5a notes. Now we're looking at measures of position. Where is a data value with respect to all the other data values? The first way to measure position is what's called a percentile. Don't confuse percentiles with percentages. A percentage is how many you got correct on a test. A percentile is where you rank compared to other people who took that test. So they're not the exact same thing. A percentile is basically the number that has at least some percentage of items below it. So first thing is that the numbers have to be ranked from least to greatest. So for the first problem here, the numbers are ranked least to greatest. So these are the numbers of customers in a restaurant on 40 days. So they are lowest to highest as I go left to right, top to bottom. Number one wants the 65th percentile. So the way I do this is I say, all right, I want to know what 65%, so I turned it into a decimal, of the total amount of data values. There are 40 data values. If I do 0.65 of 40, that gives me 26. Now, the problem is not done. Be careful. A lot of students just think, oh, I do a multiply, I got an answer, I'm done. This is saying that the 26th value represents 65% of the numbers at that number or lower. Percentile, though, is how many are less than some number. So what you have to do is, if you get a whole number when you do this multiplication, you have to take it up to the next number. So I'm going to go up to the 27th number. Now, what does this mean? This means that I am going to tell you the 27th number of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So that number, 68, is the 65th percentile. What does that mean? That means that at this mark, second here, at that mark right there, 65% of the data values were below that mark. So it doesn't matter what the numbers are, it just matters the order that they're in. So that group of numbers up there, all of those, represents 65% of the total data values. So 68 has 65% of the values below it. It is a very strange thing initially, but you're not looking at what the values actually are themselves. You're looking at how many there are. So for number 2, the 88th percentile. So let's try another one. So on number 2, we're going to turn that into a decimal. We multiply it by how many values I have. If you do this, you'll get 35.2. So that's saying the 35.2th value, which doesn't really make sense, represents having 35.2 values is 88% of the total 40 values. Just like we did here where we took it up to the next whole number, we're going to do the same thing here. We're going to take this up to the next whole number, which is 36th. So I'm going to go to the 36th number. So 1, 2, 3, 4, 5, 6, blah, 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 10, 20, 30, 31, 32, 33, 34, 35, 36. So the number 75 in this list has 88% of the numbers below it. So again, what this is saying is that at this juncture on this list, 88% of the numbers are below that number. Quartiles are a little bit easier even. They're basically special percentiles. They're every quarter, so 25, 50, and 75. Different texts describe quartiles slightly differently. Your text, I think, does it in the simplest way, though, fortunately. The second quartile, which is called Q2, it's basically just the median. We've already done this. So Q2 is just going to be the median of the data. Well, there are 40 values. So if I split it between the 65 and the 66, dead center between those would be the median. If you average 65 and 66, you get 65.5. That's quartile 2. So that cutoff there between 65 and 66 cuts the data set in half. The first quartile is just the median of everything below. So for the first quartile, just basically act as if I'm only looking at these numbers. I'm going to go right dead center of those. Dead center of those would be between the 10th and 11th value. So I'm taking the 59 and the 60, and I'm finding the average of those. So quartile 1 is the average between 59 and 60, which is 59.5. For the last one, quartile 3, I'm going to take, quartile 3 is the median of the numbers above Q2. So basically, I take the second half of the data, and I find the middle of that. So that would be between 69 and 70. The average of 69 and 70 would be 69.5. So basically, quartile 2 is the median. Then I take the median of the first half, and I take the median of the second half. That's how I get my quartiles. These can together be put with the min and max to make a box plot. Box plot has quartile 1, quartile 2, quartile 3. Those make up your box. And then you do the whisker, which is how you may have heard of it, a box and whisker plot, down to the minimum number and up to the maximum number. So looking at this data set, we don't know what the individual values are, but we do have our box and whisker plot. So what is the central tendency of the data? Central tendency is either the mean or the median. In a box and whisker plot, we don't know anything about the mean, but we do know the median. It's just Q2. So in this problem, when it says the central tendency, it's asking for the median, which again is Q2, which would be this number right here, 33. Number 5 is asking for the dispersion. Basically, how spread out is it? The only way I can do dispersion on this is to find the range. And from last lesson, we know that the range is the biggest value, which is 72, minus the smallest value, which is 12. So my range, or measure of dispersion, is 60. And for number 6, where is the middle half of the data? Well, each one of these sections here is 25% of the data. It doesn't matter if it looks smaller. It's not a measure of like the area of these rectangles. That's 25% of the data. That's 25%. That's 25%. That's 25%. So the middle half of the data is between Q1 and Q3, basically. So where is the middle half of the data? It's between Q1, 24.5, to Q3, 44.5. The next concept to talk about, which is going to be important in our last lesson, is the z-score. Some of you may have heard of a z-score before. Some of you may have taken a statistics course before or done some statistics with the z-score. This has nothing to do with percentiles. This is a completely different animal. The z-score is how many standard deviations. Remember, we did standard deviation in 12.3. How many standard deviations? The number of standard deviations a value is from the mean. So, for example, don't worry about writing this, but let's say that the mean for some data set was, we'll make it easy, 10. Let's say the standard deviation, S, was 2. If I said, hey, what is the z-score for the number 14? Well, the question is, how many standard deviations is 14 from 10? Well, each standard deviation is 2, so 1 standard deviation, 2. It'd be the z-score, the z-score for 14 would be the number 2 standard deviations. Now, if something is below, like let's say the data value was 4. 4 would be 1, 2, 3 standard deviations, because remember, each one of these hops is a distance of 2. If I'm below the mean, if I'm below the middle, then my z-score would be negative. And in this case, it would be 3, because it was 3 hops below. So just a little feel for what a z-score means. Okay, so we do have a formula, because those numbers I gave you were nice, pretty numbers. Not every number is a perfect amount of standard deviations. So we do have this formula, z equals x minus x bar over s. So on number 7, 2 friends, Cyrus and Aisha, taking different history classes, had midterm exams on the same day. Cyrus's score was 86, while his class averaged 73. We're going to find his z-score. So Cyrus's score, that's going to be the x value. So 86 is going to be the x value for Cyrus. We're going to minus the mean for his class. His class averaged a 73, it said. And we're going to divide by the standard deviation for his class, which was 8. This is, that's a z. This is the z-score for Cyrus. If you run these numbers, you get 1.625. So this is basically saying Cyrus was a full standard deviation and then a little more than half of a standard deviation above the middle. Aisha apparently has a harder history teacher. Her score was 78. Again, this is a z-score. Her class averaged a 69, and they had a standard deviation of 5. if we run those numbers, we should get 1.8. So this means that Aisha was a full standard deviation and then 0.8 of another one, almost another full one, but not quite. So relatively speaking, who did better? Well, while Cyrus's raw score of 86 looks better than Aisha's 78, in comparison, Aisha's Z-score is better. She's farther above the middle. So actually, Aisha did better, relatively speaking. Okay, we'll do the back side of these notes on the next video.